Hello students, this is Pallavi Poojar from Biotechnica and this is our last day of solving PYQs for the NEET examination, and now you are completely ready to give your best in your upcoming NEET examination, that is on Sunday, right? So today this is your last chance to join me. So please join me faster so that we can start the PYQs as much as possible early. So students who are there, so just let me wait for 1 to 2 minutes, then I will go for the solutions. Okay, Datek has joined right now. Hello Datek, how is your preparation? All right, I know that definitely you are going to join me as much as I will solve at least 2-3 questions. Okay, so we'll start with the question. So the first question is the correct statement regarding the basicity of the aryl amine is. So they have given 4 statements. You have to tell me the answer. In the description box where you can see the boxes, the options are being shown. So you have to just choose the correct one. Okay. So coming to the option A, the aryl amines are generally less basic than alkyl amines because the nitrogen lone pair electrons are delocalized by the interaction with the aromatic ring pi electron system. And secondly, aryl amines are generally more basic than alkyl amines because the nitrogen lone pair electrons are not delocalized by the interaction with the aromatic ring pi electron system. And the option C is aryl amines are generally more basic than alkyl amines because of aryl group. And option D, where aryl amines are generally more basic than alkyl amines because the nitrogen atom in aryl amines is sp hybridized. So they have given the correct statement between 4 options. So just you have to tell me the correct one. Yes. So Datek has answered me. It is option A. All right. So let us look at the answer. So it is option B. All right. So just what you have to consider here between alkyl amine and aryl amine. Okay. So just consider R NH2 is your alkyl amine and Ar NH2 is your aryl amine, right? So Ar NH2, what you can consider here, just let me show you in the next slide. Okay, so now you have your, one sec. Okay, so now you have your benzene, and upon this you have your amine group, right? So amine group you have. Now you have the simple CH3 NH2. Okay, so between alkyl amine and aryl amine, if you want to compare the basicity, so basicity in the sense what the electrons must be easily available to donate, right? So in case of aniline, what happens? The electron pair are readily available. That's why means which are not involved in the conjugation overall. That's why these are easily available, and aryl amines are more basic compared to the electrons whatever present in the alkyl amine. So the alkyl amine, when you consider with respect to aryl amine, bit lesser basic. Okay, so this is what the answer you have with respect to this question. Now coming to your next question, the magnetic moment of 2.83 Bohr magneton is given by which of the following ions? So options 4, you can see 4 options, that is Mn2 plus, Cr3 plus, nickel 2 plus, and titanium 3 plus. So just in reverse way you have to calculate the magnetic moment. So already they have given the magnetic moment 2.83 Bohr magneton, that is N value they have given, and square root of N into N plus 2, the calculation part you have, right? The formula, apply it. Just let me know what answer you can give. Okay, the new student just now she has joined, Geeta. Yes, she has joined it as option D. Okay, what about remaining students? So just you have to reverse the answer. Okay, so previously whatever the questions we have solved, there you are going to calculate the number of unpaired electron. Accordingly you are calculating the proper answer with respect to the given question. In this given question, what you can see, they have already mentioned the magnetic moment as 2.83 Bohr magneton. Now you have to tell me which ion it is. Okay, so Mn, chromium, nickel and titanium you have. So just let us look at the answer. So the answer is option C, that is nickel plus 2. So how you can solve this question, as I have told. So here already this formula you have to apply. Okay, so the formula is being already given, and now your duty is to just calculate accordingly. So just substitute 2.83 in the value of n, right? And you have square root of n into n plus 2. So just keep it as it is, because you don't know the number of unpaired electron, because you don't know the ion which one it is, right? Now coming back to 2.83 you have, so just you have to square it. So you have this square here, right? Okay, so just you have to take it to the left hand side, then you can square it. So 2.83 square, you will get the answer as 8, right? And just simplify this, n into n will be n square, right? So n into 2 will be 2n, right? Then n square plus 2n minus 8 you will get, and upon simplification you will get the n values as 2 and minus 4, right? So this is what answer you are getting overall, and where you have got n as 2, right? So minus 4 it is not possible, right? So plus 2 is possible. That's why in the given options, if you look at here, okay, so just let me show you here. So you have the option C where nickel is having plus 2 oxidation state, right? So like that you have to solve the questions. Now coming to the next question, the correct increasing order of trans effect of the following species. So they have given the trans effect series. Better you know, in case of coordination chemistry, like, so there you have the trans effect series, right? So now you have to tell me which series accordingly. So option A you can see B, C, D. So in the means in the boxes you can see A, B, C, D accordingly. So just tell me which option you can choose, the right one. Okay, so NH3 CN Br C6H5 you have. So your duty is to just think or just recall which one will come first accordingly, the trans effect. So trans effect better you know, right, in coordination chemistry. So just let me know what answer you will get here. It is very direct question. So if you know the trans effect series, then definitely you are going to tell me the answer here. All right, so Datatech has answered it as option C. I guess this answer is for this question only, or else this is for the previous question, Datatech. Okay. All right, so just let us move with respect to the answer. So the answer is option B here. Okay, so we know that trans effect in coordination chemistry, right? Suppose you have any complex like square planar complex you have. So you have your square planar complex like this. So you have Cl here, and here there is NO2, right? So now what you have to do? You have to treat with NH3. So NH3 is next ligand which is approaching towards the platinum, right? So now whatever the ligands which are present here, so it will guide the upcoming ligand towards the platinum, right? So now in case of this, the two possibilities are there. One is cis form, another one will be transform, right? So another one will be transform. Now coming to cis form, where you can get the complex like this, Cl, okay, and here you can have your NH3 and here your NO2. So this is what the coordination, that is square planar complex, you will get. And now when you consider with respect to the trans one, where it will be chlorine here, and NO2 here, okay, NH3 here. So with respect to this trans effect, you have one trans effect series, right? So the trans effect series, if you look here, so this is what the order we have, right? So this is what the order you have with respect to this, and that's why the option is B. Option B is correct here. Okay, so this is what you have. Now let us move on to the next question. Okay. So the next question, as you can see, a given nitrogen containing compound A reacts with tin over HCl and followed by HNO2 to give an unstable compound B. So the compound B is unstable, and that compound B on treatment with phenol forms a beautiful colored compound C. So with the molecular formula, they have given molecular formula, that is C12H10N2O, and the structure of compound A is. So now your duty is to find out the structure. Okay, so now you have your corresponding options, that is A, B, C and D. Okay, so just let me know the option what you will choose here. So the hints what I can give here, just let me highlight it. So what they have given, A they have given. Okay, so a compound whatever they have mentioned, it is containing nitrogen. So in the given all options you have nitrogen, right? So you have nitrogen, right? And then you have to treat with tin over HCl. So tin over HCl is what type of reagent, that you must know what type of reagent it is, whether oxidizing or reducing agent, and based on that you are going to answer me. And then what you have to do, the product whatever you will get, then you will treat with HNO2. So just by looking at HNO2 you will remember one famous reaction, right? Then after that you will get your product B. So this product B they have treated with phenol. Okay, phenol, and you will get your final beautiful colored compound, that is colored compound, in the sense that might be dye, right? So that might be dye you are getting at last, and with the molecular formula it is C12H10N2O, right? So it is C12H10N2O you have, and what answer you will get here? Okay, so what answer you will get here? So just let me know. Okay, Datek has answered it as option A, and Mallikarjun has answered it as option A. Okay, so just let us look at the answer. It is option B. Okay, so as I have told previously, okay, so the hints I had given you, what I had given you, that is tin over HCl they are using, right? So just let me choose the pen here. So they are using tin over HCl. So if they are using tin over HCl, then it is reducing agent. So it is reducing agent. Then what you can give one, means what you can get one hint is, whatever the reactant part you have, there might be presence of one oxygen at least, right? So there might be one oxygen at least. Now coming back to the options, whatever you can see the options, option A, C, B, D. So B and D where at least one oxygen you can see, but in A and C almost you have aniline and cyanobenzene, right? So now just let us go with respect to solution. So if you consider nitrobenzene, okay, if you consider nitrobenzene, we know that just upon reduction, that is reducing agent I am writing here, it is nothing but tin over HCl. Okay, so just upon reduction you will get aniline as a product. So you will get aniline as a product, right? So now after that what they have done, next they are treating with HNO2, right? So they are treating with HNO2. So HNO2 we know that specifically during diazotization we use HNO2, right? So HNO2 plus HCl, right? So here whatever we are using earlier also NaNO2 also, right? So NaNO2 over HCl, it was giving me HNO2, right? So this HNO2 what it will be doing, so it will be generating nitrosonium ion. So that nitrosonium ion, okay, that nitrosonium ion, so it will be attacking by this lone pair of electron present over the nitrogen, which are mainly present in the aniline molecule, right? So what you will get here, you will get your diazotized product. So you will get your diazotized product N2 plus Cl minus, right? So next what you are going to do, nextly they are treating with phenol. So they are treating with phenol, okay, phenol. So here overall you are going to remove HCl molecule. So if you remove the HCl molecule, then what you can get here, okay, so just let me show you in this way. So the hydrogen here, it will not go, the hydrogen will go from para position. Okay, so just let me show here, OH is as it is, and the hydrogen from here, it will go along with chlorine and it will give you a beautiful dye product. So N double bond N, and here you have your benzene ring, okay, and here you have your OH, okay. So this is what dye you are getting, yellow dye, Okay, so this is what the answer you have got. So whatever the option they had given, nitrobenzene and benzamide, you have right. So here the option B is correct. Okay, so the option B is correct here overall. Okay, and now let us move on to the next question. Okay, so the next question is like this: the correct order of the strength of the carboxylic acids. So they have given three types of carboxylic acids. Now you have to tell me which carboxylic acid has the higher acidic strength. Okay, so option A, B, C, and D. 1, 2, 3 and 2, 3, 1. Okay, 3, 2, 1 and 2, 1, 2, 1, 3 you have, right? So just think about the effects whatever present in the organic compound. So whatever the effects you can remember, inductive effect, resonance effect, everything. So just accordingly you have to tell me the answer here. Okay, so what answer you will get, student, here? So think about the carboxylic acid position and any electronegative atom is present in the structure. If it is there, then what type of effect you can apply, and accordingly you have to tell me. And the oxygen where it is exactly present, whether it is third position, first position, and how exactly you can consider with respect to the inductive effect. Okay, so just let me know what answer you will get here. Okay, so just let me wait for 1 minute. So look at the carboxylic acid and the oxygen in the given three structures and think about the electron density between the oxygen to carbonyl carbon. Okay, then accordingly you can answer me perfectly. So Mallikarjun Nilkund has answered it as option A. All right, so just let us look at the answer is option B. Okay, so why it is so? Why it is option B? Why not option A and D? Okay, so why it is, because when you consider minus I effect, okay, so when you consider the inductive effect, because of inductive effect, what happens here? The electron density will be withdrawn by the oxygen towards it, right? So the effect will be more in case of 2, right? The second carboxylic acid, whatever you can see, and that's why this proton will be released easily. So the bond between the oxygen and hydrogen is polarized highly between the second and third structure. In third structure also you have the oxygen, but the position if you look at here, so this is exactly opposite to this carbon, right? So here, so one position is differed. So here if you consider this is 1, 2, 3, so here if it is third position and here it is on fourth position, right? So fourth position you can see, that's why the distance is maximum in the third structure. We know that with respect to inductive effect, when you are considering the inductive effect in any molecule, as you increase the distance, the effect will be less, right? So the effect will be less. Accordingly, the answer will be where? It will be option B. So the answer will be option B here. Okay, that is 2 first, 3 then 1. So in case of first structure, you can see there is no any oxygen, right? So if you show the inductive effect, it will be towards this, right? So the arrow I can show like this, right? That's why the option B is correct here. Okay, now let us move on to the next option. Okay, so the Vaishnavi has answered it as option B. Yeah, very good, Vaishnavi. Now, so the sixth question, as you can see, the reactions of aqueous KMnO4 with H2O2 in acidic conditions gives. So just you have to treat KMnO4 with H2O2 and let me know what answer you will get here. So the option A, B, C and D, you can see that Mn2 plus and O2, and option B where it is Mn2 plus and O3, and option C where it is Mn4 plus and MnO2, and option D where it is Mn4 plus and O2. So just treat with the KMnO4 and H2O2 and let me know what answer you will get here. Okay, so it is in acidic condition. So acidic condition in the sense, along with the KMnO4 H2O2, you have to take any acid. Okay, it might be HCl, H2SO4 like that. So just consider and let me know what answer you will get here. It is direct question. So directly you have to treat KMnO4, H2O2 and H2SO4 if you consider. Okay, and accordingly you will get some answer. That might be Mn2 plus or Mn4 plus, and along with that O3 or else MnO2 you are going to get. So what answer you will get here? Yes. So what answer you will get here, students? All right. So just let us look at the answer. The answer is option A. Okay, so the answer is option A, where you can see the reaction like this. So you have your KMnO4, okay, KMnO4, and you are treating with H2O2, right? And in acidic condition, so you have to consider H2SO4. Okay, so I have considered H2SO4 as acid, and KMnO4 it will be 2 mole, and H2O2 5, then it will be 3 if you consider. Here you will get, okay, so just let me erase one arrow here. Okay, so now you will get O2, along with that manganese sulfate you will get MnSO4, okay, and here you will get water also, that will be 8 mole, and apart from that you are going to get your potassium sulfate. Okay, so this is what the product you are getting, and here you can see O2 and MnSO4, right? So MnSO4, where you can see KMnO4 to MnSO4 formation, where manganese is going to the oxidation state 2 plus, right? So the oxidation state will be +2 in case of manganese sulfate. So the answer has to be option A here. Okay, now let us move on with respect to the next question. Okay, so the next question, as you can see, this is regarding the diprotic acids. So this is also very easy question regarding their atomic size. You have to compare. Okay, just let me know the answer what you will get. And before that, the question is, acidity of diprotic acids in aqueous solutions increases in the order. So they have given 4 options, A, B, C, and D. Okay, so option A, where H2SE and H2S, H2T you have, okay, accordingly, and option B, where H2T, H2S, H2SE, and option C, where H2SE, which is less than H2T, then less than H2S, and option D, where H2S is less than H2SE and less than H2T. So just apply the concept of atomic size and let me know what answer you will get here. Okay, so just let me know what answer you will get here. Okay, so previously we have discussed so many questions regarding the acidic strength also. So as we move down the group in the periodic table, what happens with respect to their acidic strength, basic strength, right? So already we have discussed so many questions on this. So just same logic you have to apply and let me know what answer you will get. So the answer, Dirtek has answered it as option D and Mallikarjun has answered it as option D. Okay, so just let us look at the answer. Yes, very good, student. So the answer is option D. Perfect. Okay, so why is it so? As I have told, in the periodic table, when you move down the group, so the size will be increasing. Size is increasing. If size is increasing, accordingly, the acidic strength also decreasing. Why? Because the bond dissociation, if you consider the metal hydrogen bond, if you consider, so the metal size is increasing, then it will be easily detaching the hydrogen. That's why the acidic strength will be increasing. Okay, so it will be increasing down the group. So the answer is perfect. Let us move on to the next question. Okay, so the 8th question is regarding the adsorption of gas, that is spontaneous adsorption of a gas. So the which of the following statement is correct for the spontaneous adsorption of a gas? And A, B, C, D options already I have mentioned here. Okay, so I have already mentioned here in the box. Just you have to let me know whether it is A, B, C, or D. Okay, A is where delta S is negative and therefore delta H should be highly negative, and delta S is positive and therefore delta H should be negative. Delta S is positive and therefore delta H also be highly positive, and delta S is negative and therefore delta H should be highly positive. So just let me know with respect to this answer, this question. Okay, what answer you will choose here. So what concept you can means you can remember here, the Gibbs-Helmholtz equation you have. So think accordingly and let me know what answer you will get. So there in the equation, delta S has positive sign or else negative sign. So based on that, you are going to answer me this question. So Vaishnavi has answered it as option B and Detek has answered it as option B. Okay. Mallikarjun has answered it as option B. Okay. Okay. Just let us look at the answer. Okay. So just let us look at the answer. The answer is option A. So as I have told, the Gibbs-Helmholtz equation, that is delta G is equal to delta H minus T delta S you have, right? So the entropy is decreasing. So entropy is decreasing in the sense it has to be negative, right? So delta S must be negative. So the option, if you look here, the delta S is negative, and therefore delta H should be highly negative. So this is what the answer with respect to this question. Now let us move on to the next question. So the ninth question, as you can see, just you have to identify A and predict the type of reaction it is. So they have already given you the reactant. Okay, so they have given you the reactant and the reagent also they have mentioned NH2, and now your duty is to the finding or predicting the product, along with that what type of reaction it is, whether it may be substitution, elimination, addition. Okay, so what answer you will get here, just let me know. So just treat NaNH2, and before treating NaNH2 with the given organic molecule, you must know whether it is acting as a acid, base, nucleophile. Okay, so what exactly it is. So what you will do here. So just let me know what answer you can get here. So try accordingly. Okay, so just think that NaNH2 is base. Okay, I will give one hint that NaNH2, if it is base, then where it is going to abstract the proton. If once it abstract the proton, then it might be giving some intermediate, right? So it might be giving some intermediate just by removal of one leaving group. So which one will be leaving group in the given organic molecule? And then you are going to attack your nucleophile in the carbon deficient center. Okay, and then you will get your final product A. So what answer you will get here? Okay, Detek has answered it as option A. Okay, what about remaining students? So what your answer here? What is your answer? Already I have given so many hints regarding the given in the given reaction. So NaNH2 already I have mentioned it is base. So just let me know what answer you will get here, remaining students. Okay, so just let me answer for this question. So as I have told, NaNH2 is base, right? So NaNH2 is base, then this NaNH2, what it will do? It will grab proton from this carbon. Okay, so once it grabs proton from the carbon, then what you will get? You will get the C6H5 with OCH3 and Br you have here as it is, right? So after the removal of this proton, you are going to get one intermediate. I hope you heard regarding the benzene, right? You heard the intermediate benzene. So now the benzene intermediate is being formed here. So this benzene intermediate will be formed once this Br goes out. So just let me show here perfectly. Okay, so you have got your benzene here. Okay, so just I have shown before leaving the Br group. So firstly what happens, the NaNH2 is a base, it will abstract the proton from the carbon center, and then the Br will be going out. So this Br will be going out and you are going to get your benzene intermediate. So after the formation of benzene intermediate, again you have your NaNH2. Okay, so compared to this carbon and this carbon, so this carbon is more electron deficient. Why? Because it is very near to this oxygen here overall. Okay, so this carbon is mainly polarized, and overall this NaNH2, so NH2 will be gone acting, means it will be attacking to this carbon, and you will get your ortho product, that is OCH3 here, that is NH2 here. So firstly you have eliminated and nextly you are adding, right? That's why what is your answer? So the answer should be option B here. So what is your answer? It must be option B. Okay, now let us move on to the next question, that is 10th question. The compound C7H8 undergoes the following reaction. So they have given so many reactions. Okay, so the reaction they have given and the product they have mentioned there. Okay, so C7H8 to 3Cl2 you are treating, upon heating you will get the product A, then again Br2 with Fe you treat, then you will get some product that might be B. Okay, and then upon treatment with the zinc over HCl you will get product C. Okay, so what is your product? So they have given the options A, B, C, D. You can see 3-bromo, 2,4,6 trichlorotoluene, orthobromotoluene, metabromotoluene, parabromotoluene. So what is the product you are getting starting from C7H8? So just they have mentioned the molecular formula. They have not given any structure here. So what is your answer here? Okay, so first one hint what you can notice here, the given options A, B, C, D, if you look at the options A, B, C, D clearly, where everywhere you have toluene as a product, right? So you have toluene. Apart from that, on toluene you have different substituents. So the reagent whatever in between they have used, because of that reason you are getting your second substituent on the benzene ring, right? So no doubt your starting material will be toluene only, right? So it will be toluene, and I have given you one hint that C7H8 might be toluene, right? Now take toluene and treat with 3Cl2 and heat it, you will get one product, that is A product. Okay, then that A product you are going to treat with Br2 in Fe and you will get the product B. That product B you have to treat with zinc over HCl, that is reduction reaction, and what product you will get? Just let me know the answer here. So already I have given so many things regarding the reaction. Okay, so just let me know what answer you will get accordingly. So C7H8 is toluene, already I have mentioned, and it is direct question. So just let me know what answer you will get here. Okay, I will only answer the question. Okay, so no need of complicating the question. What they have given? They have given C7H8. So C7H8 is nothing but it is toluene. Already I have told, that is C6H5 CH3 you have, right? So C6H5 CH3 you have. Next, what step they have given? They have given 3Cl2 over heat, right? So DTech has answered right now. It is option C. All right, just let us look at the answer. So now you have your toluene. Okay, so toluene you have. Before that, just let me go to the answer part where you have the option as C. Okay, so option C you have to get. Okay, let us look at the reaction part. Now you have your toluene. Okay, now so firstly they have treated with what? Firstly they have treated with 3Cl2 over heat, right? So just upon that, let us look at here. So just upon treatment with 3Cl2 on heating, you will get C6H5 Cl3. So all the hydrogens are replaced by chlorine. Now next what they have done, so this is what the product A you have got. Now they have further treated with Br2 in Fe, right? So here Fe in Br2 when you have, so CCl3 and Br will be attacking at third position, meta position. Now apart from that they have given tin over HCl. So tin over HCl is a reducing agent, so it will kick out all the hydrogens and you will be getting your toluene back, but it is derivative. So you have got your substituted toluene, that is 3-bromotoluene you have got, or else metabromotoluene as the answer you have got. If you look at the options, in the option C you have it, right? So you have the options. Option C is correct here. Okay, now let us move on with respect to Next question. So the next question, as if you can see, which one of the following exhibits DD transition and paramagnetism as well? So they have given the MnO4 minus, Cr2O7 2 minus, CrO4 2 minus, and MnO4 2 minus. So just let me know what answer you will get here. Okay, so you have to start with their electronic configuration with respect to the given metal center, right? So just let me give you hints here overall. So first go through their atomic number, okay? And so just try to remember their atomic number and electronic configuration, right? So upon electronic configuration with respect to their charges overall, if you consider, that is oxidation state, and definitely you are going to get the correct answer. So what answer you will get here? So if you consider MnO4 minus, so Mn is in what oxidation state? So accordingly the oxidation state you have to consider, and now you have to think with respect to their electron available, how many electrons are available, and based on that you are going to answer me. Okay, so what you have to do? Okay, so Vaishnavi is asking me how it is. Okay, so just let me give you one hint just by taking option A. So you have MnO4 minus, right? So minus you have charge, and Mn, if you don't know the oxidation state, so first you have to find out the oxidation state. So before that, try to find out the oxidation state. So X you have to consider MnO4, right? So X plus oxygen, where you consider minus 2 charge, right? So 4 oxygens you have equal to minus 1, right? So you have minus 1 charge, so I have considered it as minus 1. Now X, so 4 into 2, that is minus 8 you will get, and here you have minus 1. So X is equal to 7 you will get as the answer. So minus 8, if you shift here, it will be positive, and already minus 1 you have, it will give you 7, right? So you have got the 7 oxidation state for Mn. Now you have to think about its atomic number. What is its atomic number? It is 25. So if it is 25, how you will fill the electrons? D5 S2, right? If it is S2, then what you have to consider? Overall 7 oxidation state you can consider with respect to MnO4 minus, right? So if you consider, then here overall you have 5 plus 2, 7, so it will be D0 S0 state, right? So it has no electron with it. Accordingly, calculate with respect to B, C, D options and let me know in which option the given compound the unpaired electron is present. If there is unpaired electron, then definitely it will exhibit the paramagnetism and DD transition. Why it is so? So just let me know what answer you will get here. Okay, so Vaishnavi has answered it as option D, and Datek has answered it as, okay, so Datek has trying to answer me regarding manganese plus 6 and 3D1 oxidation state something. Okay, Pavan has answered it as option D. All right. So accordingly, if you solve with respect to all the given compounds, you will get answer D as an option. So just let me go back here. If you look here, so MnO4 minus already have solved, and similarly, if you solve with respect to CrO4, that is Cr2O7 2 minus and CrO4 2 minus, you will get the oxidation state as plus 6. Okay, so you will get the oxidation state as plus 6, and when you solve for the MnO4 2 minus, you will get the answer. Okay, you will get the answer like this. So just let me solve for that. So when you consider MnO4 2 minus, so Mnx you have to consider, right? And oxygen, it will be minus 2 into 4 and equal to minus 2. So it will be x minus 8 is equal to minus 2, right? So you have minus 8. So it will shift that side. Minus 2 will be as it is, plus 8, right? So 8 minus 2 will be 6, right? So x is equal to 6. And overall, you know that manganese, where D5S2 you have, right? So overall 7 electron. So 7 minus 6 will be 1 electron. So 1 electron is left then. So 1 electron left in the sense that definitely it will be exhibiting the paramagnetism, right? And it will undergo DD transition also. So the option D has to be correct here. Okay. So you have got my point definitely. And if you have any doubt still, you can ask me in the chat box. Okay, Mallikarjun has answered right now. It is option D. Yeah, very good, students. So all of you have answered it as option D, and your approach is also perfect. Okay, let us move on to the next question. So the next question, as you can see, the geometry and magnetic behavior of the complex NiCO4R. So they have given the NiCO4 complex. Now you have to tell me what exactly it has the geometry and its magnetic property. So option A, it is square planar geometry and paramagnetic. And option B, where it is tetrahedral geometry and diamagnetic property. And option C, where it is square planar geometry and diamagnetic. And option D, where it is tetrahedral geometry and paramagnetic. So what answer you will choose here? Okay, so here what hint you can notice. So one thing what they have given, that is nickel complex they have given, right? And now the ligand what they have given, whether it may be weak ligand, strong ligand. So based on that, now you have to tell me whether there will be pairing of the electron, or else if there is no pairing of the electron, and means in the d orbital of the nickel. Okay, d orbital of the nickel, whether if there is the pairing of the electron, you will get one geometry. If it is not, then you will get different one. So based on the ligand nature, you are going to predict the answer. You are going to predict the answer with respect to its geometry and their magnetic behavior also. So what answer you will get here? So firstly, in order to answer this question, you must know the atomic number of nickel and its oxidation state, okay, the D and S configuration, whatever you have. And particularly when you have the coordination chemistry, that is D block elements, whatever you have, at least 30 elements you have to mug up. Okay, if you know, then definitely you are going to answer me this. So what answer you will get, students, here? So just let me wait 30 seconds. Yes. So I have given half of the answer already, and now just let me know what answer you will get here. So Vaishnavi has answered it as option D. All right. Okay. What about remaining students? What is your answer? Okay, Mallikarjun has answered it as option B. Okay, so the answer is option B here. So why is it so? Okay, why is it so? So just let us look at nickel complex. So NiCO4 you have, right? So NiCO4, where carbonyl is a strong ligand, right? So it will try to pair up the electron in the d orbital. Now nickel is in its zero oxidation state. Okay, so it is in zero oxidation state. What is the atomic number for nickel? You have nickel oxidation, that is atomic number is 28. And if you consider its electronic configuration, that will be D8S2. So it will be D8S2. Then D8S2, in the sense overall you have to fill the electrons, right? So just let me consider d orbital first. 1 2 3 4 5 d orbitals and 1 s orbital. So 8 electrons you have overall. So just try to fill 1 2 3 4 5 6 7 8, right? And in the s orbital you have 2 electrons, right? So this is d and this is s. Now because of the presence of this strong CO ligand, it will try to pair up the electron. So just you have to pair up the electron, and if you pair up the electron, then you will be noticing one thing, that it will be undergoing further the next s and p orbital hybridization. So it will be p orbital, so it will be sp3 hybridization, and there will be no, means there will be any other unpaired electron, right? That's why it will not exhibit any paramagnetism, and it will be showing diamagnetic property, right? So in the given options, what they had given, that is option B, tetrahedral geometry and diamagnetic property, right? So diamagnetic property, as you can see here, just let me choose different highlighter. So tetrahedral geometry and diamagnetic property. Okay, so the answer option B is correct here. Okay, now just let us move on to the next question. So the next question, as you can see, ethylene diamine tetraacetate ion is. So what type of ion it is? So they have given the 4 options: hexadentate ligand with 4 oxygen and 2 nitrogen donor atoms, and option B where it is bidentate, that is unidentate ligand, and option C where it is bidentate ligand with 2 nitrogen atoms, tridentate ligand with 3 nitrogen atoms. So what type of ligand it is? So just let me know the answer, what you will get here, whether it is hexadentate, monodentate. Okay, so what answer you will get here? So the answer will be based on the nitrogen, oxygen, and how they are going to bind with respect to the metal atom. Okay, and based on you are going to answer me. So coming to here, this question, if you check overall, so the oxygen, nitrogen, how exactly they are binding. So with respect to that, you are going to answer me. Okay, so here, if you consider with respect to this question, the answer will be option A. So option A will be what? It will be hexadentate ligand. So if you look at the structure, that is ethylene diamine tetraacetate CH2. Okay, so it has bound to 2 nitrogen. Okay, so nitrogen you have, and apart from that, this nitrogen where you can see it will be having CH2 and COO minus. Okay, again here also CH2, COO minus, and similarly here also it is CH2, COO minus. Okay, now here also it is CH2, COO minus. So you have how many oxygens? You have 4 oxygens, right? So 1, 2, 3, 4 oxygens you have, and apart from that you have 1 nitrogen here, 1 nitrogen here. So 2 nitrogens, 4 oxygens you have, and whenever you have any metal center, so just let me choose here with different ink. So you have metal center and it is going to bind. So it is going to bind in this way. So this oxygen is also binding to this metal center, this nitrogen, okay, and this oxygen here, okay, and again this oxygen and this nitrogen and this oxygen. So it is hexadentate ligand, right? So it is hexadentate ligand, and the answer has to be option A. Now let us move on to the next question. So the question 14 is, in which one of the following arrangements the given sequence is not strictly according to the properties indicated against it. So they have already given few compounds. Okay, so they have given increasing acidic strength, increasing pK values, increasing acidic character, increasing oxidizing power. So accordingly you have to answer me what answer you will get here. So option A, B, C, D you have already I have mentioned. So just let me know what answer you will get here. So just notice with respect to the given reasons. Okay, so acidic strength, pKa values, acidic character, oxidizing power. So what answer you will get here? So the answer might be pKa value, acidic character, oxidizing power, or acidic strength. So acidic strength when we will consider, so with respect to their atomic size you are going to consider. So just let us look at the answer. It has to be option B. So the option B is against whatever they have mentioned. Okay, so just consider with respect to the second option, just let me highlight it, H2O. Okay, so H2O, H2S, H2SC, H2T, so increasing pKa values they have given, right? So increasing pKa values in the sense down the group the acidic strength must decrease, right? But we already concluded that acidic strength should increase, right? So if it is increasing, then the pKa value has to be decreasing. We know that acidic strength is always inversely proportional to pK value, right? So that's why the answer has to be option B here. Okay, now let us move on to the next question. The hydrocarbon A reacts with bromine by substitution to form an alkyl bromide, and which by Wurtz reaction is converted to gaseous hydrocarbon containing less than 4 carbon. So whatever the product you are getting at last, it has less than 4 carbon. So whatever the molecule you must get, it has to be less than 4 carbon. So what answer you will get here? So the hydrocarbon A, you have to treat with first bromine, you will get one product. Okay, that will be substitution, simple substitution. And just by looking at the options, you can answer me perfectly. And one hint I can highlight here. Okay, so one hint I can highlight here, it is firstly substitution reaction, right? So if it is substitution in the given option, so you have to choose the options wisely, the two options where you can do substitution easily, right? So in B and D, if you consider, the addition reaction will be faster, right? So A and C, where you can do the substitution reaction, right? So between A and C, that might be one answer. So just let me know what answer you will get here for this question. So try to take CH3 or else CH4 and try accordingly with bromine and try to substitute. And after that you will get alkyl bromide. That alkyl bromide you have to treat with Wurtz reaction, okay, that is sodium in dry ether, right? Then you will get your gaseous hydrocarbon. But whatever the product you are going to get, just you have to remember one thing, that whatever the gaseous hydrocarbon you are going to get, it must be having less than 4 carbon atom. So if you consider here, okay, so Datek has answered it as option A and Vaishnavi has answered it as option B. Okay, so just let us look at the answer here. Okay, so just I will try to solve here. So just consider this is hydrocarbon A. If it is CH3 and CH4 you have, right? So we'll solve in the next slide itself. So the answer will be option C here. But also I want to show with respect to A and C both. Okay, so now you have your CH3, okay, and you have CH4. So this is your option C and this is your option A. Now CH3, if you treat with bromine, okay, so if you treat with bromine, so you will get here your CH3, CH2, Br, right? And you will get here your CH3, Br, right? And now after that, they are going to treat Wurtz reaction. So Wurtz reaction they are doing, right? So Wurtz reaction where you are going to treat with 2 moles of Na, right? So 2 moles of Na and here also 2 moles of Na. Okay, so just let me change the slide ink. Okay, now so after treatment with Na, you are going to get CH3, CH3. Okay, here in the first option A, and option B, whatever you are going to get, so it has to be 2 moles here. Okay, so it has to be 2 moles, and here you are going to get just simple CH3. Okay, so you are going to get the simple CH3. If you start with CH4, you are going to get CH3, that is ethane you are getting. If you are starting with ethane, you are going to get butane. But what they have mentioned already, whatever the product you are going to get, it has to be less than 4 carbon atom. So the answer has to be option C here. Okay, so the answer has to be option C here. And now let us move on to the next question. Okay, so which of the following compound can form a Zwitter ion? So you have to tell me the direct answer just by looking at the options itself. You can tell me the answer. So the benzoic acid, aniline, acetanilide, and glycine you have, and which compound has the Zwitter ionic form? Okay, so what answer you will get here? So first, before that, before answering the question, you must know what exactly is Zwitter ion. So Zwitter ion is a dipolar ion. So in a single molecule, you can have positive and negative charge, right? So that is what the Zwitter ion you have. So Datek has answered it as option D. All right. So the option D is correct here. Yes, glycine is the molecule where you have your Zwitter ionic form, because when you consider the amino acid, so it will be having NH2 along with COOH, right? So it will be having COOH, and that's why, so here it will be having positive charge and here it will be negative charge overall, and that's why it will be having what? Zwitter ionic form, right? So all amino acids if you consider, so you can say that glycine is an amino acid and it will exist in Zwitter ionic form. So the answer has to be option D here. Now, coming back to the next question, the H2O2 with O3 it gives me H2O2 and 2O2, and H2O2 with Ag2O, it is giving me 2Ag along with water and O2. And the role of hydrogen peroxide in the above reaction is, so your duty is to find out what exactly hydrogen peroxide is doing in first reaction and second reaction. So if you want to answer this question, so you have to find out the oxidation state of each and every element, whatever they have given. Okay, O3, Ag2O. So what exactly it is doing? So just let me know what answer you will get here. So the option A, where oxidizing 1 and reducing 2. So in the sense, the 1 in the sense the first reaction, 2 in the sense the second reaction. So their characteristic is being given, whether it is acting as oxidizing or reducing agent. Okay, so oxidizing 1 and oxidizing 2, you have almost. So what answer you will get here? So Mallikarjun has answered it as option C, and Vaishnavi has answered it as C. Okay, Datek has answered it as option D. All right, so the answer is option A. So hydrogen peroxide is acting as oxidizing agent in first reaction, whereas in the second reaction is acting as a reducing agent. So if you look at the reaction here, so H2O2 you have, H2O2 you have. Okay, so now with respect to the first reaction, if you consider, with respect to the first reaction, if you consider here, so the O3, which is in zero oxidation state. Okay, so where you are going to get H2 along with that O2. Okay, so here O3 to O2 formation. Okay, and H2O2 to H2 formation is reduction, but O3 to O2 formation is oxidation reaction. And similarly here Ag2O in the presence of H2O2 is undergoing reduction reaction, and self it is undergoing oxidation, right? So we know that oxidizing agent is the one which oxidizes others but undergoes self reduction, and reducing agent reverse, so it will reduce others, undergoes self oxidation. So like that, the concept if you apply here, so the answer has to be option A here. Okay, so like this way you have to solve so many questions, and finally all the very best for your NEET examination, and definitely you are going to give your best in your NEET exam. Okay, and have a good hope on your future, and definitely always we are with you. And if you have any queries, anything means any help you want from Biotechnica, and we are always ready to help you. And if you have anything to say, then you can say in the chat box. And again, with respect to any other concept, or if you want anything, so you can join our Telegram channel also, where you will be having so many notification regarding your NEET examination, and definitely those are useful for you. Okay, till that, thank you, bye bye, and once again all the very best, all the very best for all of your students. Okay, all of you from Biotechnica.